So what is a pure function? Well, a function is pure if we give it the same input, we always get the same output, no matter how many times we call that function. So it shouldn't have any side effects. Let's take a look at a few examples. So this function is impure because every time we call it, it's modifying its argument. So if the value of the count property of the input is initially 0, and we call this function 10 times to increment it, instead of getting 1, we get 10. So in a pure function, we should not mutate or modify any of the arguments. Here's another example. In this function, we're making backend calls via this service. And this is an example of a side effect. So every time we call this function, our application state stored in the database on the server is modified. And here's the third example. In this function, we are updating the value of the count property based on a random number generated by the mass class. So with this function, if we give it the same input, we cannot ensure that we always get the same output. The output is different every time because we are using an impure function. So in a pure function, we should not use mass.random or date.now or any other functions that return a different value every time we call them. Now let's take this first example and change it to a pure function. So instead of incrementing this count property, we return a new object with a count property, and the value of this count property would be the value of the original count plus 1. If we call this function 10 times and give it the same input, we always get the same output. So if count is initially 0 and we call this function 10 times, we'll get 1 because this function is not modifying its argument. So in Redux, our reducers should be pure functions. Now let's take this example and modify it a little bit so it looks like a reducer function in Redux. In Redux, reducer functions always take two arguments, the current state and an action. Then, based on the action type, they return a new state. So typically, we use a switch statement on the type property of the action, and based on the value of the type property, we return a new state. So let's imagine action.type is increment. Then we return a new state with the updated property. So we are not going to modify the original state passed to this function. Now, if you have never done functional programming before, this concept is new and confusing to you. I totally understand that. So you might be asking, what is the point of this? Why are we not allowed to mutate or modify the state? We always have to return a new state. Well, there are a number of benefits to this approach. The first benefit is that pure functions are really easy to test. Imagine you want to write a test for this function. You don't need any mocks, any spies, or any other tricks. You simply call this function, give it an input, and make an assertion about the output. As simple as that. The second benefit is that this approach makes it really easy to implement features like undo and redo, because we always keep the previous state instead of modifying it. And the third benefit is that it gives us a powerful tool which we call time travel debugging. So using the tool that I will show you later in this section, we can travel back in time and look at our application state as different actions are triggered in the application. We can see how the application state is modified in every step. And this makes it really easy to find bugs and fix them. But once again, it only makes sense if you're building a complex application with complex data flow. For a calculator application, you don't need Redux. But if you have complex views, complex data structures, and things have to be modified in different places, then you can look at the application state and see exactly how it's modified.